Today we're going to learn what is Docker about, and we're going to actually be doing a practical example of Docker with a Node.js application. So let's get started. So before I get into what Docker is, the importance of Docker, and why big tech companies use it, I just want to bring to light the different companies that actually use this technology. And ChatGPT, I asked ChatGPT here, and it gave me a lot of different companies, right? Google is using it, Amazon is using it, Microsoft is using it, Facebook is using it, Netflix is using it, Uber is using it. You can see my point being that this is an in-demand skill that you should know as a developer. All right. And you can see ChatGPT also goes as far to show us how each company is using it. Right. So yeah. And for the most part, they're using it for deployment, which is what I'm going to be teaching today. Anyways, before we get our hands dirty now with the Node.js application and containerizing it, right? I want you guys to understand the fundamentals of Docker, the theoretics, because once you understand the theoretics and you know you understand the base knowledge, it'll be much more easier for you to go ahead and get your hands dirty. All right. Before we do this, though, it's really important that you have Docker installed on your local system. So for that, you can just type in Docker install and then your operating system. In my case, I'm using a MacBook. So then you can just go to the top link. It's going to be docs.docker.com, and there should be a big blue button for downloading, and you should be good to go after you're done that. All right, cool. Now that we know that, let's talk about the Docker basics. So before I get into these basic fundamental concepts, which are Docker file, Docker image, and Docker container, it's important to understand what Docker is on a high level overview. Basically, Docker is a technology that helps us run a piece of software seamlessly on any hardware out there, right? This means that your app will be consistent on different environments, such as your development environment, in this case being my MacBook, or your EC2 instance on Amazon, which the broader audience will be able to use, right? Will be able to access, right? So with all these different environments, it ensures that it runs consistently, all right? And basically that means that it's more reliable, all right? And this is a huge issue in the developer community, especially if you work professionally or you've actually scaled an app before without Docker. There are many times where, me even personally, where my app would work on my local machine, right? But then as soon as I push it to a new environment, such as giving it to a fellow developer or pushing it onto a server on the cloud, it stops working. It breaks. And the main reason for this is the environmental configurations change, right? They change between these environments, right? Because it's not an isolated environment, right? Your Node.js or whatever app you have. But what Docker does is it isolates it within a container, okay? And what this means is that now all your environmental configurations and everything you need for your app to begin are within this container, all right? That's why it's called a container. It contains everything, right? And so now, if you switch between production to development or to your fellow developers' development environment, it won't affect your specific software, right? It should work without any problems because all the environmental configurations, including the variables, versions, all of that is the exact same, right? And the way that it's able to do this is through the Docker image. So the Docker image includes everything that the software needs to get running, right? Additionally, includes all the configurations, right, which are your environmental variables and software versions, etc. Like I just talked about before. And essentially, it can be thought of as a snapshot. All right. And what do I mean by this? Well, I mean a Docker image is immutable. That's just a fancy word for it cannot change. Okay. And since this Docker image cannot change as soon as it's built, it means that all the configurations that you made have no chance of being altered when you push it to new environments. All right. Therefore, your app, if it was working on a development environment or whatever environment that you had before, it should work on the new environment that you're trying to run this Docker image on. Okay? Now, that is what a Docker image is. It basically powers all of the Docker functionality and all of this cool things that I'm talking about, especially about the fact of it being more reliable and consistent. But a Docker image by itself cannot run. It's not executable. All right. That's where we use a Docker container. Essentially, a Docker container runs a Docker image. It can be thought of as the executable copy of a Docker image. Okay. So each Docker container will be based off of a Docker image that we built. All right. Now, going back to Docker images, all right, to build a Docker image, we need specific instructions, right? Or else how are we going to configure the environmental configurations and what software to run, what commands to run? We need all of that so that it runs seamlessly, right? So we can do that with the Docker file, all right? And as you can see, I literally wrote here. It's simply the instructions to build a Docker image. It can be thought of as the DNA of the Docker image if a Docker image was an animal. All right. So with that little analogy, let's go ahead and start getting our hands dirty. So here in Visual Studio Code, I actually have created the Docker file, all right, or the DNA for a Docker image. I'm going to go ahead and run through each and every setting and piece of code so that you can understand it better. Additionally, I have another Docker file, which is a Docker ignore file. I will explain this more further when we're more into the Docker file image configuration. So first, we need a base image. Okay, and what is a base image? Well, basically, a base image is what our Docker image is based off of, right? Hence the name. Okay, so in this case, we are actually pulling it from Docker Hub. Now, Docker Hub is essentially just a registry of all different Docker images that we can use. Like there's operating systems here. There's these development images as well, like Node, right? There's a lot of different types of software that you can run with Docker. But in this case, we are just using Node because, we obviously want to run a Node app within a Docker container, right? Which is, again, just a runnable instance of a Docker image. Then we have to define a work directory. So this is where we're going to put all of our Docker files and the Node.js files in this case, so that the Docker container knows where to get it all, right? So in this case, we're just going to put it in /app. Doesn't really matter where you put it. It's just a doc set to put in /app, so that's where I put it. Now we need to copy our package lock and package JSON file. We do it with only one command, and that's because we actually added a wildcard here, which is this little thing over here. So what it does is it finds all the files with starting with package, and funnily enough, package -lock and package JSON both have package at the start, so it copies both. So we're basically getting two files within only one command. It just allows us to have less amount of code. And we need this for the next command, actually, which is npm install, right? And again, we need to run npm install, obviously, because there are different dependencies in which your app relies on. Then we're going to go ahead, and once we have all our dependencies, we're going to go ahead and copy everything. All right, so these two dots do exactly that. It's going to copy all the source code for us. But then there's actually a problem here, because this is copying from our local environment into our Docker container, right? But the problem is that there's actually a node_module in our local container, not in our Docker container, but in our local container. But then the problem arises is that when we run our npm install, right, which we run before the copy, another node_module file is built. All right, so then the problem is that there's two node_module files. So in order to avoid any potential errors from having two different folders, I should say, with the same name, we have to create a Docker ignore file, same as a git ignore. So it's going to start off with the dot, and then it's going to be Docker ignore. All right, and then inside of here, it's the same context as git ignore, right? You're just going to put in node underscore modules like this. You're just going to type that folder in. And so Docker knows that it's going to copy everything except that node underscore module file because it already has it within its environment. So it doesn't need it from the local environment. Then we're just going to expose the port. This is done so that within our Docker container, that port now has the Node.js application within it. All right. And it has to be the same as the port we're running our app on. So just make sure it's the exact same. Then we're going to run our start command. So we use the command, and then this is called an executable. So instead of running it like in a shell type of format like this, it's much more preferred to run it like this, where you put your commands words within an array. All right. So that is the Docker file completely done, or our DNA for our Docker image completely done. So now Docker knows how to build an image, which is perfect. All right. So you can go ahead and copy this code, right? Heck, I even copied it, but it's just the idea of understanding it, which is really important, which I just did for you. Okay, now we're gonna go ahead and jump into our terminal. Okay. So first important thing is to change directories into your Node app. I have it as test node, and it's in my base directory. So it's just going to be cd test node. There we go. Now we are in test node. Now what we can do is start building our Docker image. This will allow our Docker container to run because it needs a Docker image in order to run, right? So to build a Docker image, you just want to run Docker image /t, sorry, not Docker image, my bad. Docker build /t, so that's a tag, so we're going to name it. I'm going to name mine my cool app. And then dot. This dot refers to the directory within what you want to build your image on, right? And we want to build our image with the test node directory because that contains our node app, right? Now I'm going to press enter. It's going to do its thing, and you can see it's very, very fast. And there you go. It is done. Now, what are we going to do? Well, we're going to run docker image ls. Watch what happens. There you go. You can see the image that we just created. The Docker image has been officially created. How cool is that? All right. And this command, by the way, just for context, is how you can get all of the Docker images that are currently built. So there you go. We have created our Docker image. But if we try running this Docker image, there's no way of running it, right? By itself, at least, because the Docker image cannot be ran. Instead, what we need to do is we now need to create a Docker container. And the way that we do that is with the run command. So we're going to do docker run, all right? And then I'm going to do /d. This just means detach mode. And essentially what that means is it's going to run in the background and it's not going to keep running on the terminal, so I can keep using my terminal, all right? This is a completely optional option, right? You don't need to add this if you don't want to. Then this is very important. You need to add a /p. So what we're going to do now is we're going to perform a port forwarding. Essentially, our Docker container is isolated. That means that the 8080 port that we're exposing will not be able to be used within the local environment. Because again, it's an isolated environment, right? The Docker is isolated. Okay, so what we're doing is we're port forwarding it so that the 8080 port is being forwarded to our preferred port on our local environment. Therefore, it can be seen on our local environment. In my case, I'm going to forward it to the 3000 port, and then we obviously have to add the port with which the container is running on, which is 8080. Well, for clarity, just we should think of it as a Node.js app is running on port 8080 within the Docker container. Okay, anyways, docker run /d, optional, then /p, port forwarding, very, very not optional. You need to have it, or else it will not run. Okay, and then we have to go ahead and add our image, right? Because again, a Docker container is based off of an image. That's what it uses to run it, right? If you don't have an image, it doesn't know what software to add, it doesn't know what dependencies to add, it doesn't have any direction, right? So the Docker image provides the blueprint to actually start the server, or sorry, start the container, I should say. So in this case, there's two options, okay? So you can go ahead and add in the image ID or the image name. Both work the same. In my case, I'm just going to use my cool app, which is my Docker image name. If you use the image ID, it will work the exact same. Now, let me press return. As you can see, it allows me to use my terminal now. It doesn't keep running the process, right? That's because we're running it in detached mode, so it runs in the background, as I said before. And now it also gives me a ID. This ID, all right, is the container ID. And we can further see it through Docker PS. This command shows us the different containers that are currently around, right? Currently running. And if I run this, you will see that it says created 30 seconds ago, which makes sense because, it's been about 30 seconds. And you'll see that the container ID matches the container ID within here, right? So that just proves that the Docker run command creates the container uh, that we need, all right? And now if I go back to Google Chrome and I go to localhost 3000, as you can see, it's actually running my app. And I can see that because if I go into index.js, in my slash, I am actually running hello world. And I can also go to the slash Google route. As you can see, it works. And now, let's say I want to stop my container. We're not deleting the container, but we're just stopping it. So we can just run docker stop and then the container ID. In this case, you can use the shortened form or the login form. Both work. I'm just going to use the shorter form. And as you can see, it will give you a message back, just giving you the ID again to just show you, just tell you that it stopped. And if I go back to my my web browser and I try running this again, as you can see, it goes ahead and stops. All right. So now, how do we delete a Docker container? Well, before I answer that, there's actually something else I want you guys to know. So when you actually go ahead and install Docker, you'll get a Docker desktop, all right? And this is very important because right now I'm doing everything through the CLI, right? But you could do stuff through the you can see stuff through the Docker desktop too, right? As you can see over here, I see the image that I created, and I can see the different containers that I have too, which is here right now, right? So it has a name like this, but you can also use a /t to go ahead and name it whatever you want as well. All right. So I can also start it again. So Docker start, and then give the name to, and then it just goes ahead and starts it again, as you can see, right? But now let's go ahead and figure out how to delete a container. All right. Sorry about the technical difficulties. My Wi-Fi went down. But while my Wi-Fi was down on my phone, actually through data, I was able to figure out that what I said to you guys was wrong. All right. With Docker containers, when you build them, I said you can use the /t tag and you should be able to add a custom name. Well, that is wrong. You actually use a -- name method like this. Okay. And this is in the official Docker docs, so you can trust it. And I actually tried it out too. So here we go. Right now, I do not have any Docker containers. So we know that if you use the PS, it gives you the Docker containers. But one thing that I didn't mention to you guys is it only gives you the running Docker containers. So if you have a Docker container, but you stopped it, right? Again, that's not going to delete the Docker container. It's just going to put it on idle, right? But if you run the PS, it won't be there, right? So to actually see all of them, right, whether they're stopped or running, you use a -a shorthand or option. And as you can see, right now, I do not have any containers. I do have images though, which is just one, as you can see. And so now what I'm going to do is I'm going to run docker run, right? I'm going to go ahead and build it, -d. I want it to run on background, port forward it, right? 8080. And then what I'm going to do now is I'm going to give it a name of --name, right? And then I'm going to give it a name of my cool container. So this will give it the custom name. And then I'm going to add in the image, which is my cool app. Make sure that all of your options that you have come before the image. If you add any options after the image, they won't be configured. All right. So make sure they are before you go ahead and specify what image you're going to be using for this specific container. We run this. You can see it's very, very fast. It has started. All right. Now what we can do is we can run docker ps-a. And as you can see in names, it's using my custom name. And you can now see that we actually have a container running. All right. And if we stop this, right, docker stop my cool container, you can either use the name or the container ID, doesn't matter. And if I do docker ps, you'll see that I don't get any containers. And this is what I mean, right? And that's because I stopped my docker container. But if I use a docker ps-a, it'll actually give me that container regardless if it's on or off or whatever state, okay? So just use a docker ps-a to get all of the containers. Anyways, yeah, that's just something I wanted to show you guys. Now to delete a docker container, this is what you do, right? Because docker stop, as I did before, it just stops the container. It doesn't delete it, right? You can still start up the container through docker start, right? Because again, docker run is not a docker run is actually going ahead and building your docker container. So it builds it and then it starts that container, all right? But now to restart a container, you're not going to run docker run again because that's going to build a new container. You're just going to run docker start and then specify the specific container that you want it to run on. All right. So in this case, we want to run my cool container. All right. And when I run this, as you can see, it starts it because we get the ID back or the name back. And if I actually go to localhost 3000, you can see everything works perfectly. Now, if I run docker stop my cool container, I run this again, you can see it can't be reached. So to delete a docker container now, we're just going to run docker rm. And then you can put in the name or the ID, right? Again, with docker, you can either add the name of that image or container or the ID. Both work completely the same. Now that I've done this, all right, if I do docker ps-a, again, this will give me all the containers regardless of their state. You'll see it's gone. All right. And again, obviously, this is not going to work. Now, to delete a Docker image, it's a little bit different. All right. You're not going to use the RM shorthand. You're actually going to use the RMI. All right. So let me go ahead and clear everything. And let's just get the Docker images, right, which is through that command. And as you can see, we have one image, which is my cool app and this ID. Now, what we're going to do is to delete it is we're going to run RMI, my cool app. And once we do this, as you can see, it gives us deleted. All right. And if we actually see now in Docker image ls, you'll see that we have no images left now. So I'm left with a clean slate without any containers, without any images in my local machine. Now, obviously, all that I showed you guys was all in a local machine, but you can do this on a production environment through Linux or anything. Same commands apply. Just make sure you install Docker CLI through your Linux server. All right. So that's it for me. I hope you guys got some knowledge and gained some value from this. I'm out.